Hi everybody, so today we're going to look at empirical formulas and their calculations, and we're specifically going to be looking at the 2013 question 4e question. And if we're reading it there, it states when hydrogen gas is passed over 1.59 grams of copper oxide, 1.27 grams of metallic copper were produced, find by calculation the empirical formula of copper oxide. Okay, so there's a lot going on here. Okay, and we know we have to figure out what the number of moles is of both copper and, if we're looking at it there now, oxygen. Okay, because we're told, if you're reading it there, that copper oxide, CuO. Okay, now we don't know what the actual empirical formula is of it. Okay, we just know that there would be copper and oxygen in it. So we must figure out the number of moles of both copper and oxygen. Okay, so I'm going to rub that out and start off. So first off, we're told that 1.27 grams of metallic copper were produced. Okay, so we're dealing with copper over here. Okay, so therefore, number of moles is simpler mass over mR, and 1.27. And if we look at the empirical form for the mass number for copper is 63.5, and you're going to get 0.02 moles copper. Okay, so look, I'm just going to actually underline that there, put a box around it. We'll come back to that now in a second. Now our next one is going to be oxygen. So we have to figure out the number of moles again of that. So we have to figure out what the mass is and the mR. So the mR we know is going to be 16. And the mass. Now, we have 1.59 grams of copper oxide. And when that was passed over hydrogen gas, we were left with 1.27 grams of copper. Now, mass cannot be created nor destroyed. Okay, so if we simply get 1.59 minus 1.27, I'm putting that into my calculator now, we're left with 0.32 grams. Now that 0.32 must belong to the oxygen. So 0.32 divided by 16, and you want to get 0.02 moles of oxygen. And again, we'll put a little box around that. Now, we must compare them, and we always use the lowest number, but if we're looking at it, in this case here, they're actually the same. So it's 1:1 is what our solution is going to be at the very end. So it's actually going to look like this, CuO. Okay, so that's our answer there, okay? Now, if you guess that and threw that into your as down as your answer, okay, you're not going to get the marks. You have to show the workings out for these ones, for the empirical formulas. Okay, drawing down CuO as I did at the very beginning, I didn't know what the answer was going to be, isn't going to get you any marks. You have to show it. And all you have to do is get the number of moles of how many of the reactants you're dealing with, copper and oxygen in this case, and you're good to go.